Hi, good day everyone.
Hopefully.
Right. I believe I can start, right?
Go for it.
All right, good. So again, good day everyone. We're going to talk about the coming minutes about why we need sustainable data architectures, what they are, right, and how you could build a sustainable data architecture. That's the plan for the coming minutes. But I think the story starts here. As we all know, many companies have started their digital transformation initiatives. They are trying to become more data driven. They're thinking about becoming part of the data economy. They think about data disruption type aspects. Now, I know these four terms or five terms don't really mean exactly the same thing, but what they have in common, yeah, is that they all mean that the company or the organization wants to do more with data, right? If you want to become more data driven, it means you want to do more with data. And doing more with data probably means that you want to improve, let's say, your business processes, your decision-making processes, yeah, through the use or more effective and efficient use, yeah, of data. I think bottom line, yeah, that is what all these terms mean, right? Doing more with data. But if companies start all those projects, initiatives, one of the first things they do is, of course, they look at their existing systems, right? The systems that deliver data to the business processes and to the decision-making processes. And unfortunately, what a lot see is that those existing systems, of course, they do their jobs, but they are not really good if you look at the more newer data requirements. If you think about doing more with data, and then very quickly, organizations make that decision. Let's build a new data architecture, one that is suitable, yeah, for all the new data requirements that we have. The whole "we want to do more with data" story. Now that's interesting, of course. Building data architecture, new data architectures. Now the point, however, is you don't want to build any data architecture. You want to build a sustainable data architecture, and a sustainable data architecture is adaptable. And with adaptable, I mean is that if data requirements change, yeah, that the architecture that you have can adapt to those. That it's relatively easy, yeah, to make changes to it. So sustainable data architecture can not only meet the current requirements with respect to data processing, but also the new ones, right? The ones that we know will come up, and then hopefully also the requirements that we don't even know about. Imagine that in 2 years' time, your organization will acquire another organization that can have a major impact on your data architecture. It's just you don't know, right? So these architectures have to be as adaptable as possible. Yeah, so to make them sustainable, very important adaptability. But to be honest, that is easier said than done. So let's sort of build up this story. Yeah, first for me, yeah, these are the key requirements of a data architecture that could qualify as sustainable. I think it should support definition independence. And with that, I mean that if you change, let's say, the definition of a specific concept, let's take something very simple. You want to change the length, yeah, of a column somewhere in a source system, or you want to split a certain table in two for some, I don't know, performance reasons, technical reasons, conceptual reasons. Now, currently, in most architectures, even these sort of tiny changes, yeah, can lead to a tsunami of changes throughout the architecture, which means a lot of work, right? So you will be able to implement that change, but still it will take a long time. Adaptability also means that you can do this quickly, right? That if something changes, if a definition changes, that you can make that change fast. Another one is technology independence, right? If new technology appears on the market and it's very valuable technology for you, you want to be able to adopt that within the architecture and not by working on it for years and years and years. No, easily, right? That's important. Runtime platform independence, that's important. Imagine you have your architecture currently on-premise platform and you want to move the whole thing to the cloud. It should be easy, right? Your architecture should be adaptable enough to make that possible. Distribution independence, meaning that if you want to have half of your architecture on premise and half of it on a certain cloud platform, or maybe on two different cloud platforms, you should be able to do that, right? The architecture should not restrict you in making that change. And then, of course, architecture independence. A very classic data architecture is, of course, the data warehouse architecture, right? The traditional data warehouse architecture with its staging area, data warehouse, its data marts. But nowadays, we also see data lake architectures, data hub architectures, data lakehouse architectures, data fabrics. I think an architecture should also be flexible enough, adaptable enough, so that you can easily sort of transform it into one of the others. Sometimes we want that because, let's say, the requirements with respect to data change, or let's say data consumption forms change, and we need a more data lake-ish kind of solution than a data warehouse kind of solution. And the list goes on, right? Design principle independence. Imagine that you now have a standard for storing, let's say, sensor streaming data in certain tables. Imagine that you want to change that. In fact, in the ideal world, you just indicate that that style of storing sensor data has to change. You just want to do it once, and then wherever it has been implemented, it should be changed almost automatically, right? And then we have metadata independence, history independence. History independence means how do you want to deal with history and the history of data in your systems. Now, this is a long list of requirements. I do want to discuss a few of them, let's say in a little bit more detail, just to really explain what I mean, and I need them in the second part of my talk. So, for example, the definition independent thing, which I think is very important. If you look at these, again, as I said, these classic data warehouse architectures, and I think most of you are familiar with this, right? If we have to change the column length of one column, right, in one of the source systems, it can really lead to a massive amount of changes throughout the entire architecture. We have to change the ETL programs that read that column. We have to change the table that will contain data from that column. We have to change the ETL program that copies the data from the staging area to the warehouse. We have to change the program that copies it from the warehouse to the data marts, and so on, which may look like a simple change, can be a lot of work to do. That does not make the architecture more adaptable. And this is just a simple one, right? Imagine we want to split tables, drop columns, and all that stuff. It's so that older architecture is not definition independent, right? The definitions are all over the place, and if we want to make a change, we have to change all those definitions. It's not part of a sustainable data architecture. Another one that I mentioned is technology independence, right? If valuable technologies appear on the market, you want to be able to adopt it. And as most of you know, there are, well, lately, the last, 5, 6, 7 years, we've gotten a number of very powerful new SQL database engines. There was just a talk on Snowflake, but the same applies to the Microsoft Synapse product or the German Exasol product. These are very, very powerful analytical SQL database servers. Maybe we don't see that from the outside, because from the outside they look like any other SQL product, but their internal architectures are so different, so powerful, so scalable, that in fact, that if we would use them, they could simplify our data architectures. So if I take that classic data warehouse architecture again, and most of these architectures are still designed like this, right? With staging area, data warehouse, physical data marts, and you probably have to do that if you use sort of traditional SQL technology. But with these more powerful analytical SQL database servers, maybe you can just build a much simpler architecture, where there is no need for physical data marts and no need for a separate staging area. Maybe this analytical SQL technology is powerful enough to handle the entire workload. Now, if it can, of course, it's going to make your life a lot easier, right? Less databases to manage, less coding to do, right? Because there's only one ETL layer left. The adaptability will be much better, right? Because it's simpler. And we can slowly move towards more zero data latency, right, for the reporting. While in the original architecture, that's not really possible. But imagine that technology is there, right? And you have this feeling that you can benefit from it. Most existing architectures, I mean, it's not so easy to transform them into that second architecture. So exploiting the power of that new technology is not an easy thing. Yeah, in an ideal world, if you have a sustainable data architecture, this change should be easy. So that if new technology appears and it's great, then you can exploit it. Of course, you will have to do some work, yeah, but it should be limited, right? This is just one example, right? Here's another one with GPU databases. I'm not sure whether you've looked at those. These are SQL database engines running within graphic cards, right? And they will exploit all the parallel execution power, yeah, of those graphics cards. What we're seeing in real life is that they are incredibly fast, very simple to use, incredibly fast. Imagine that that's exactly what you want, or maybe I should say that's exactly what your users want, right? Fast performance, regardless what they do, regardless of the complexity of the queries, they want to have, yeah, sort of millisecond response times on every query that they do. Well, maybe you want to switch to GPU databases. Then your architecture should be adaptable enough, yeah, to sort of adopt that technology. That is what we mean with sustainability. And here's another one. If you look at all the different types of database servers, especially the SQL ones, right? You have general purpose database servers, which are good at everything. The ones on the left and bottom side, they're good at everything, but they don't really excel at something. Next to that, we have the transactional database servers. They excel at doing transactions, but they're not that strong in analytics. Next to that, you have the analytical SQL database servers, the ones I just talked about. They excel at doing complex queries, massive amounts of queries, but transactions is not their strongest point. But now we have this new category called translytical database servers. Some call them unified database servers or HTAP database servers. So these database servers are built, optimized, tuned, yeah, to run an analytical workload, a high-end analytical workload, and the transactional workload, yeah, concurrently. Now that is very special, right? So general purpose database server can also do that, but not high end. These products have been built for that. Now, if you sort of think about that and then think about architectures, yeah, that could mean that the older architecture could be replaced by just this, right? That you have a translytical database server and it processes your entire reporting analytical workload and concurrently your transactional workload. Now, I'm not saying, and please do this, but imagine that the technology is there and you have an extremely good reason for adopting this stuff. You want to be able to adopt it easily, right? And that is what a sustainable data architecture should be able to deliver you, right? Now, I'm not going to go through all the key requirements because that would take too long, and I don't have that much time, unfortunately. But I hope you're sort of getting the message. It should be easy, right, to adapt your architecture to new data requirements. And that could mean adopting new technologies, adopting other cloud platforms, that kind of stuff. Now, but then how? And I think one of the better ways of building sustainable data architectures, is by adopting generators. Now, generators are not new, right, to the IT industry. We've had generators for I don't know how long, right? And in fact, generators, the topic of generator, is of course linked to the topic of automation. And in principle, that is what we do, right, in our industry. And we've been doing that for a very, very long time. This is our business, right? We automate, business processes, manual processes, factory processes. This is what we've always done. And I believe Herman Hollerith, was one of the first, to do that, in a real life environment. And Alan Turing, of course, did his work in automating, certain processes. Now, to be honest, I think the IT industry is really, really good at automating processes, right? Factory processes, marketing processes, finance processes. We're really good at that, but we're not that good, yeah, at automating our own processes, right? And for me, an IT process is, for example, developing an ETL program or designing a database or programming, right? Just plain, programming. I mean, these are our processes, but we're always hesitant, right, in sort of adopting automation for our own processes. And that's a little unfair, right? So we're happy to do that with other people's work, but not so much for our own work. Well, we have to be honest, right? Automation works well, yeah, for processes that are highly repetitive and formalizable. Well, I'm thinking about ETL programming, for example. I've done ETL programming. Some of you have probably done ETL programming. And I must admit, I find ETL programming highly repetitive. Imagine that you have to write a lot of ETL code that will extract data from a data vault based data warehouse and then sort of copy that data into a data mart that has star schema patterns. And let's be honest, you're going to see just a limited number of patterns, yeah, on how to do that. That you go like, oh, that's formalizable, right? That's repetitive. That means we could automate that, right? And why don't we automate that? Well, to be honest, it has been automated. It's just that in a lot of projects, it's just not being used. And I think it's not just ETL programming, right? I think there are a lot of tasks or processes that we do, yeah, that can be automated because they are repetitive or formalizable. And of course, AI, right, even helps us a little bit further, right? Even if it's not 100% formalizable, then with AI we can still get close. But I must admit, if we what is it recommend companies to go for generators to automate certain tasks, there's always resistance when we do that within the IT industry itself. And the most classic argument against this is always performance. You always hear stuff like, well, generated code is never as efficient and as fast as handwritten code. And you go like, I think it's the other way around, because the people that build the generators will have to make sure that the code they generate is as efficient as possible, and they get a lot of time to make that as efficient as possible. But still, there's always resistance, and sometimes it's coming from what you could call tool jockeys, right? People who once learned a certain job, how to develop ETL programs or how to design star schemas, and they prefer to stick with that, right? They like that, and you go like, yeah, okay. But we can automate your process. But I think it is time because it can help us, yeah, to make that move to sustainable data architectures. Because for me, generators, automation means the following, right? It means development acceleration, so that we can build much more quickly. And very important for sustainable architectures, maintenance improvement. So if we have to make changes, that we can make them fast and easily, right? It's important. We, in most cases, see a performance improvement, that the generated code, yeah, it comes from the generator, and the generator is built by people with a lot of expertise, and they've done it for years and years and years. Quality improvement, and with quality improvement, I don't mean data quality improvement, but more, let's say, the quality of the code that is being generated. Yeah, a generator, if it generates correct code, it always generates correct code. If we do stuff by hand, that's not always the case. Of course, you're listening here, you're attending this event. Of course, your code is always perfect, but you have other people who do not always write perfect code. Generators, if the generator works, it generates correct code. It's that simple. And it will give us developer independence, right? We're not so much dependent on the quality of individuals anymore. No, because the generator will generate the same level of code, right? Same level of quality. Technology independence, I see that as a big advantage. Yeah, imagine that a generator now generates for an Oracle database if suddenly the generator has to generate for a Snowflake database or an Exasol database or a single store database, then well, we have to change the generators, well, something in the generator just once, and then we're done, right? Well, if you have to do that by hand, it's a lot of work, right? So it'll make the move towards other technologies much easier. And then, in sort of in respect to that, also vendor independence. The only thing is, you're going to be dependent on the vendor of the generator, right? I'll come back to that in a minute. Right now, does it mean that we have not been using generators at all? Now, if I focus on the world of business intelligence, data science, data lake, big data, that kind of stuff, of course we have been using generators. Maybe we don't call them generators, but they are generators. Yeah, most of the high level ETL tools, for example, they're all generators. You specify your ETL program in some kind of a high level language, and then it will generate low level code to do the real work, right? We use data modeling tools, right, that can generate data vault structured databases. They're generators. We have generators. Well, most of the BI tools are generators, right? Because they generate SQL statements to extract data from our databases. The only thing is, these generators all generate just one tiny component of the entire architecture. Plus, they don't really share specifications, right? What you're going to see in these types of environments is that the definition, yeah, of a table, for example, could be within the repository of the ETL tool, within the repository of the modeling tool, and within the repository of the BI reporting tool. So they're not really sharing specifications. They're not integrated, right? So therefore, we have data warehouse automation tools, right? Data warehouse automation tools can generate the whole enchilada, the entire architecture, let's say. So we specify, let's say, our data models, we define our concepts, and then from there, it can generate all the components that make up the architecture, but from one repository. So one repository with shared, specifications. That, of course, is better, right? It makes more sense, so that we won't end up in inconsistent specifications or whatever. Now, personally, I've always been a big fan of this, using data warehouse automation tools, because for me, a lot of the work, development work that's being done within these traditional data warehouse architectures, is very repetitive. If you do this in a structured way, it's very, very repetitive. So we should be able to build generators for this. And then the big advantage of this is, of course, that if we want to change something, right? So if you want to change let's say the central data warehouse is now an IBM DB2 environment, and you want to switch, let's say, to Starburst, for example, the only thing we have to do is make sure that the generator understands all the specifics of Starburst, and then we'll just regenerate, right? I mean, we have to do it, but the amount of work that you have to do there compared to if you have to do this by hand, I mean, the difference is enormous, right? And that will make the architecture more sustainable. The only limitation of some of the data warehouse automation tools is that they are aimed at this specific type of architecture, the data warehouse architecture. And as I said when I started, and I'm pretty sure that you know this, is that we have all these other data architectures nowadays, right? Logical data warehouse architectures, data lake architectures, data streaming architectures. What if you also want to change your architecture, right? You want to move away from your more traditional data warehouse thing to a more data hub kind of thing. Now, if you have to do that by hand, again, that is a lot of work, right? So what you want to have is a generator that can help you to make the move, to another type of data architecture. Maybe you have to do it in 3 steps, 2 steps, 4 steps, but if you have to do it by hand, it's a massive amount of work. With a generator, your productivity will be better, right? Maintainability will be better, and that's what we're interested in. It will make your architecture easier to adapt, even changing the characteristic, of the data architecture. Now, I'm not sure that this is already an accepted and official term, but I prefer to call these types of tools data architecture automation tools. So I'm not sort of limited to a data warehouse architecture. I can also build architectures for data lakes, for hubs, for logical data warehouse architectures, and that's definitely going to give me sustainability. Products such as Warescape, right, belong to this category, but I believe they still call themselves data warehouse automation tools. But if I were them, if I would work for their marketing department, I would call myself a data architecture automation tool. But this, I think, is what we're aiming for. So to sort of wrap up the story, I really think that the need for sustainable data architectures is high, right? You don't want to build another data architecture of which you have to say after 3 or 4 years, all right, it's already old-fashioned, right? No, it's that. No, that you can't do that anymore. The architectures must be sustainable, and that means they have to be adaptable in the same way that Darwin said that, right? The ones that are adaptable, they will sort of survive. And that is what I mean with sustainable data architectures. The architectures that will have a long and fruitful life, let's say. But how do you do that? There are probably multiple ways of doing it, but personally, I'm a big fan of the generator approach because for me, generators is independence, and independence means adaptability. And I think if you look at the world of data architectures, data architecture automation tools, that category, of generators, that is now what we need. Now, does it mean that if you just use that type of technology, then you're okay? No, you can always try to make the whole architecture even more adaptable by bringing in other types of technology that will give you adaptability. So, for example, data virtualization, and I've done a lot of work with data virtualization. That's another type of technology that also brings some form of adaptability to the architecture. And of course, you can combine that with the generator approach, right? It's not that it has to be one or the other. Everything you can do, right, to make it more adaptable, that's important because data requirements are changing faster and faster. And we have to help our organizations with that. Now, one more remark. A data architect is always dependent on at least one tool, language, or vendor. I think that's true. So yes. So if you select a data architecture automation tool to sort of generate your architectures, you're independent of many technologies. So your ETL technologies, your database technologies, and all that stuff. But I agree, you're always dependent on one. And in this case, it's probably the vendor of your data architecture automation tool. I don't think there's a solution yet where you can bend or build a fully independent data architecture. So maybe the goal should be to come up with something where you minimize the dependencies. Zero dependencies, I think that's very hard to do. All right, I think I have to stop here. My time is over. Thank you very much for listening. I'm not sure whether there are still questions or anything or whether I should answer them. But in any case, thank you very much for listening, and I hope you enjoyed it. And of course, enjoy the rest of the show.